Hello everyone, my name is Zifan Li. Now I'm a master student that study in Sunada Rajahat University. My major is public health. Today I'm going to share my research on food safety and public health. Specifically, we will look at how heavy metal pollution moves through processed seafood. I will show you a dynamic computer model we built to track this hidden danger. Let's start with the background. Today, famous local foods like Chaoshan fish balls are made in huge factories to sell all over the world. To get enough raw materials, these factories rely on deep sea fishing. But this brings a major public health risk. Deep sea fish often absorb dangerous heavy metals from the ocean, especially cadmium and methyl mercury. The biggest problem we face is our current safety rules. Regulators mostly just test the final product at the end of the line. This is a very static approach. It completely ignores how the ocean environment changes and ignores the complex chemical changes that happen during factory cooking. We call this the black box of food. To open this black box, we need a new method. We cannot physically test every single fish in the ocean. It takes too much time and money. So, we built a robust computer simulation. We combined a biological uptake formula with a factory processing formula. To test if our model really works, we generated a massive synthetic dataset. We stimulate 5,000 batches of fish transactions. We did not guess these numbers. We based our simulation parameters on real, historical environmental data for the South China Sea ecosystem. So, what did our computer simulation reveal? First, we discovered a significant time delay. In the ocean, the dirt and sediment are most polluted during the summer because of heavy monsoon rains. However, the fish do not become highly polluted immediately. The model showed a 3.5 month gap. The highest pollution in the fish tissue actually happens in the autumn harvest. What does this mean for us? It means if regulators test the water and the fish on the exact same day in the summer, they will get a false sense of security. Second, we found that factory processing acts as a double-edged sword. Let me explain. When the factory washes the fish meat, it successfully removes water-soaked cadmium. Our model showed the risk score dropping to 0.71. This is good news. But the mandatory heating and drying process is very dangerous for organic compounds. Heating removes water, but it leaves the mercury inside the fish. The food shrinks, but the poison stays. The risk score actually goes up to 1.12. This proves that even if the raw fish was legal and safe, the final cooked food might become toxic. To conclude, our traditional static testing is simply not enough for modern food safety. We must use dynamic computer models to predict these time delays and cooking concentration effects. This framework will help us move from just recalling bad food to actually preventing the danger and offering personalized diet advice. Thank you very much for your time and attention.